Dua also presenting about the visualization and loading of data pre-processing of MRI. And now I am starting the basic steps of MRI pre-processing. Are you? I think so. I share my screen. Are you seeing my screen?
Okay,
Everybody?
yes, Azam, yes, I can see your screen.
Uh,
Just before you start, I'm just going to speak for about 3 or 4 minutes, 5 minutes, and just give everyone a background on what we're doing and how it's going forward.
okay,
So
okay,
basically, we are also in process of collaborating with King Saud University and their neuroscience department. So we've been in touch with Dr. Schwag over there, and we collaborate with her. Now, I don't know if you guys on one were on one of our very initial calls. I don't think that lecture was recorded back then, so I don't think any of you have seen it. Obviously, me and Azam were on that call. So what happened was, and I'm just giving you a little bit of a background on why we're focusing on this side. Well, we were focusing on data pre-processing in terms of neuroimaging anyways, because it's a part of what we do. But we were specifically asked to do so by King Saud University as well, because currently what they're doing is they're using neuroimaging pre-processing tools like FSL or the other one, the CAT. But what happens is they have to go to one tool for one specific process, like for example, segmentation or intensity normalization, and then they have to go to another tool and for another process. But what we are doing for them is we're giving them one single tool which takes care of all these processes simultaneously in real time, and it sort of makes life a lot easier for them. In one of our earlier presentations about 2 weeks ago, I spoke a little bit about it was an introduction. I spoke about how these different processes were related to neuroimaging and how we were and how they would be helpful in the long term for data pre-processing and then building AI models and algorithms and everything. But now in this session today, Azam is going to be diving a lot more deeper on how those individual processes work. And remember, this is all a foundation for our main product, which is obviously the AI-based diagnostic tool for Alzheimer's. And before we get to the modeling and the algorithms part, it's very important that we get through this part first, because if the data hasn't been cleansed and isn't in the right state, then the modeling doesn't go there as well. It's not as accurate enough. So back to you, Azam. Please carry on.
okay. My screen is shown for everyone.
Yes.
Okay. In last lecture, the Dua also was demonstrating about the data visualization and data loading of MRI. Now, in further, there are three to more most important steps regarding to the data cleansing and pre-processing of MRI for the making of modeling. As Sir Ahmed also taught that there is very important that the data should be cleansed in a real form, then the model understand that how in a better way. Now there are first step is intensity normalization, and secondly this registration, third skull stripping, tissue segmentation, and data augmentation. In first step, we normalize our data. Normalize means we also purify. You see that in the uh, you see that in the left hand side the original image, and after the normalization our image is more cleansed. The gray part of our images is removed in the case of white part, and the tissues and other things of veins and other things part of the vein are very visible after the normalization. Now for the data modeling, We also trained our model for the different feature extractions of the brain. Now, it is very important to normalize our data. All the images are in the same pattern. And in the second step, we apply the skull stripping. Skull stripping is a process which we extract our brain from the main brain skulls. You see that the original format is that the skull and in between the axial part of our brain. And after applying the skull stripping, you see that this is that. After applying this calculation, you should see that this is the 3D view of the brain. The first view is tonal view, second is sagittal view, and third is axial view. The first view is normally over coronal view is over x-axis view, and the sagittal view is over y-axis view, and axial view is over z-axis view. And after applying the skull stripping, these part are extracted from our skull. And after applying some other algorithms like normalization and other things, we cleanse our data for the preparation of the normalization process. And on the tissue segmentation is the most important segment because this segment basically extract the feature of the brain. You see that there are different labels that MRI, this is original MRI, and after labeling that CSF mean uh, is a part of cordial flu and gray matter, GM in gray matter, WM in white matter. These all things are in the brain data. You see that after applying the tissue segmentation uh, clarify the data in the different color schema. You see that some color schema is in the yellow shade and some in the reddish shade and some part in the blue shade. You also apply different shade cards according to your requirement. But in this such case, we apply such thing for the explanation of our model. And in the next modeling phase, we also apply some prediction case, and after the prediction, we explain over all the MRI slices in the uh, explanation AI format. Uh, Now the tissue segmentation is basic segmentation area which we expect the major features regarding the MRI pre-processing. And in the last case, we
Azam,
apply.
Azam, sorry, before you go ahead, I'm just going to add something over here. If you can just come back to the previous slide with the tissue segmentation.
Yeah,
So I'm going to briefly speak about this over here. So what's how we aim to explain this is now Azam mentioned explainable AI as well, which is very, very important. Now, in the grand scheme of things, if you look at the bigger picture, the solution that we are making, the diagnostic tool for early detection of Alzheimer's. Now, you people have to keep in mind that our system is not a system which is just going to tell the physician or the doctor that, okay, this MRI you uploaded is matching to MRI which has Alzheimer's or dementia or early onset of Alzheimer's or aggressive Alzheimer's, or if it is not demented at all and if it is completely normal. Whatever diagnosis the system is going to make, the whatever solution, not solution, but whatever answer that the physician is getting from the system, it is also going to be backed by explanation or explainable AI. And that explainable AI component is going to give a solid reasoning. It is going to give a reason to the doctor. Okay, this is why the system came to this judgment. If the system is coming to a judgment, if the model is saying that, okay, this MRI you uploaded is belonging to a patient which has early onset of Alzheimer's, it is also going to give you an explanation and tell you, okay, this is why the system feels that it's early onset of Alzheimer's because it is matching to another MRI based on these factors. Now, these factors, if you dive deeper into it, which the model will, it is going to tell you what is the anomaly or what is the common factor. So it might say, okay, this lesion or this atrophy or this part of the brain which has white matter or gray matter or is matching, or whether it's the cerebrospinal fluid, whether that is matching in some specific region. So that is why segmentation is important, especially because it is segmented by color. So it makes life easier for the doctor. So the system, via explainable AI, is going to tell the doctor, okay, this is what the model thinks is going on, and this is why the model has come to this judgment. So this is very important. Azam, please carry on.
Okay. Now the other segment is in the last where we all the images after applying different data preprocessing process steps like the normalization, the tissue segmentation, and data augmentation. And in the last way, we also transform all our images in the form of template. And the MNI template is a most popular template, which is introduced by Memorial Neuroimaging Institute. Uh, and in such template, we also built a sequencing of all our Alzheimer data slices of MRI. We extract different slices view, especially this view is the Excel view shown in the MNI template. We also deal in three different dimensional image view, and all the images are templating in such template. In the further we demonstrate in practically, you better understand that how we things are doing that. Now we move to in the last segment is data augmentation. Basically, and this is not an harsh and fast case. Other images are also treating like such images, like rotation of the images, flipping of the images, some noise reduction, some brightness, and other things regarding zooming and flipping of horizontal and vertical flipping of images. These things are also are dealing some other computer vision images. But in case of MRI, we also deal that because sometime when the scanning of the MRI is processing, some images are not in the better format. Like now in such segment, we all align all the images in one pattern. No,
Azam, I'm just going to, sorry, before you move on, I'm just going to add a couple of points over here, just
okay.
for everyone's clarity. I'm also saying this because I know the session has been recorded, so anyone who comes back later to view this can also go through my comments and then see what's going on over here. So it's so that we can record it too. Okay, so there's a couple of things to keep in mind over here because our system, our model that we're building is not only computer vision based, it is also based on, it's an agentic model, it's based on large language learning models as well, LLMs. But as far as the computer vision phase of it goes, so there's two aspects to it. Now, data augmentation, if you look at the screen, so there's different ways that it can be done. So you give an input and then you can rotate the images in different directions, different axes, x-axis, y-axis. You can 5 degrees, 10 degrees, 15 degrees up to you can do. Either way, you can flip the image upside down. You can share it, you can scale it, you can increase the Gaussian noise, you can decrease it. Brightness, you can increase and decrease as well. And then you can use a different permutation and combination of these different steps as well. Now, there's two reasons we are doing it. Number one, we do it for the ease of access for the doctors. So the doctors that are viewing the report, sometimes they want to look at it from different angles and everything. So we give them, sometimes they find that the image is not clear enough, not bright enough, and they want to brighten the image or reduce intensity, reduce the brightness level. They want to flip it, they want to rotate it. So that's one thing. Number two, what we also seek to do is we seek to augment the data. Now, augmenting the data means enhancing the data set, increasing the size of the data set. Now, when we're looking at MRIs, fMRIs, and we're looking at data from patients who have Alzheimer's and dementia and Parkinson's and other neurodegenerative diseases, we have to keep in mind that data that we get for for training these models is not very easy to get. So, for example, we've been getting data from two companies. One of them is called ADNI, based in the US. The other one also is called OISIS. So these companies give us data sets that we train our models on. But so for example, the Alzheimer's model that we are training is based on a data set of more than 100,000 images which we have derived from MRIs and fMRIs from patients, which is anonymized data. It does not have the patient name and personal details. So what we then seek to do is if we want to increase the data set to increase the accuracy of the model that we're building, what we do is then we use techniques which are related to data augmentation so that we can increase the size of the data set that we have, which we're training the model on. So just like a hypothetical example, if we have 100 images, we can convert it into 500 images by rotating them, by flipping them, by sharing, by scaling, by increasing the noise or reducing the brightness. So there's a very variable number of ways in which we can increase the data set. And the reason behind increasing that data set is so that we have more data to train the model on. So it helps us in increasing the accuracy. And obviously, all these steps also help doctors if they have a specific MRI image that they want to enhance or they want to look at it from a different angle. So that's the gist of it. That's the reasoning behind that. And Azam, back to you. Thank you.
One point added that the data augmentation is also very important than for the model overfitting and underfitting. Sometimes the data set is too much low, and some classes have data set is in the number of scale that other classes is too much low. Then we add some uh, by applying some data augmentation techniques to increase the number of images in such class by increasing noising, increasing rotating, scaling, brightness, and some other ways. And this is very important from the training of our model, because if we deal different type just like that four type of classes, and our classes, one class have a data set is too much low rather than the other classes, then our model is not purely trained, because our model training is not too much overfitting and not too much underfitting. It means that if we train our model in negative examples, more negative example, but when we apply the model in the production sector, our model started predicting also the negative examples too much, very high accuracy rate, but in case of two examples, they are not understanding that. That's why we are imbalancing our class in such a way that our model is not too much overbalanced and not too much underbalanced. This is basic technique from the behind the scene of the data augmentation. Now we move forward to the practical demonstration of all these examples. In last lecture, Dova also demonstrate that how we load the MRI and how I give example of that. This is just like that. In last lecture, Dova also give example about how we load the MRI and how we visualize our MRI in a single view and 3D view. Now, just 5 to 10 minutes for the pre-processing from the understanding of the new students. We First of all, we use a Visual Studio, and Visual Studio we use Jupyter Notebook for the demonstration of our examples. You can also use Google Colab for the as a visual ID, but I suggest that you use Visual Studio, because sometimes there are some path setting and other things when we move from some tricky programs which are not spotted made on the Jupyter Notebook. We apply a simple Python programming files in the PyTorch, an explanation AI case. In case we must all build all the program in Visual Studio. That's why I suggest you, you all people know about the Visual Studio, how we install the Python and how we uh, set the do also make a GitHub repository and which also include in README file all the steps. I also upload some easy tutorial and share you in the in the lecture, which you understand that the how we built a open environment settings for the programming. Now we start that. First of all, we import some libraries for the demonstration for the processing of our MRI. First library is Nibabel. Ni mean neuroimaging. Neuroimaging Bible is most important library for dealing the neuroimaging because the library also read the 3D MRI images view and other 3D computer vision views. And the second library is NumPy library. Basically, the NumPy library is used from the mathematical calculations and the converting the images into pixel format and other mathematical operations like array and shaping of our data. This library is very popular library used for the Python, especially data analytics. And the third library is Matplotlib. Matplotlib is a library which is plotting the graph and visualizations of the MRI and other computer vision images. In computer vision, all the plottings are specifically done in Matplotlib and Seaborn. Now, if I write the code that first of all we initialize a variable to name that as you wish that I name is a test load, and in test load we use a nib library instance and load method. Load method given the path of the loading of our MRI file. As you see that our MRI has different format like a Nifty format. Now I give the path of our folder that MRI dash NIFTI, the Nifty, and we select a subject 01 NII. NII is a format of the Nifty format. Basically, there are two formats are used from the Nifty. First is dot NII and the second is dot NNI dot GZ. GZ is a zip format of our MRI because in some cases the MRI file is too much size of the MRI is by around about 100 MBs. Now then we deal uh, like 1000 MRIs, and the in MRIs we have the size more than in GPs. Now we reduce such size, we apply or convert all the our file into zip format like ni.gz. We have all to file like control that is a zip format and this is without zip format. And get f data is a method which loads the file of the MRI. And when we apply that, you see that our code is loading and give the error data set it's TII. No, it's okay. Now you see that first of all we take a shape of our MRI. The shape is means that the pixel resolution of our MRI. The first pixel resolution is that the x-axis is 176 and the y-axis is 276 pixels and the 256 pixel is z-axis. When we multiply all the this figure, we get a calculated pixels of one MRI pixel size. This is the way we calculate the total pixel of our MI. The shape is a method which gives you the accurate figure of the pixel. Now we also uh, apply some other apply the 3D view of we load the data, and after loading this is some methods. In the last lecture, Didua also presenting all the methods in detailed format. because today lecture I also mostly focus on the data pre-processing step. Now you also consider all these methods, and these things are also available in that. Now after that, I this is just like that. Wait a minute. And now this is a visualization of over MRI. We visualize that over MRI, and we apply that the one shape of our test shape over MRI. We also apply that. We apply that over test shape one. You see that after the test shape one is that shape format, and we apply that test shape four. See the because it's a 3D view. Also, we view the z-axis view or z-axis because of shape bar. If we get in the 3D images view, may take examples because it's a path setting view. All the paths are. This is basically we load all the slices of our MRI. You see that basically in MRI we have maximum 250 slices, and the middle in excess of the slices give you the better view of our MRI. Now we load our MRI, and all the slices are given in the format. You see that the different slices are uploading, and when we move to the more middle image slices, the MRI shape is more prominent. That this is basically all the slices are loading in the, and you see that this is in such slide the MRI image is more prominent. That this is basically the demonstration viewing of MRI, and we also give you some example of 3D view. This is basically the demonstration of a 3D view of MRI. Just like that, we load a MRI. MRI is available in a control. This is a shape of our MRI, and this is a Excel view. You see that this is a x-axis view, y-axis view, and this is z-axis view. If we get a y-axis view, we give one view at a time in such code, and this is the y-axis view. And similarly, if we get the x-axis view and we take 120 slide, and in such case, this is a x-axis view over MRI. And if we move forward from x-axis view 150 number slice number, we move to the 150 number slice number, and 140 is I think so the more prominent view. And similarly, when we get to the view in the shape of some other slicing view, just like that, and we move forward to the in the 3D image view, and you see that this is basically the 3D images view. And Dua also demonstrate that in example how we move. You see that there is a cursor of x-axis or y-axis cursor view, and when we move to the cursor, just like that, through the slider, you see that the cursor moves that, and the slides number of our MRI is also moving that. You see that we are over 93 number slide of the secretarial view. The secretarial view is that, and we move forward to the 66. The slide is that. Similarly, we move forward to the axial view. You see that the axial view, and this is the total number of slides. In secretarial view, we have 176 number slices. In the corner view, we have 256, and similarly, the axial view we have 20. This is all basically demonstration of how you can demonstrate your MRI in case of brain imaging, yeah, some like other cases. You also apply such code for such MRI for the demonstration point of view. Now the today lecture we are focusing on the data pre-processing. Oh, wait a minute. If somebody have a question, then ask me. Then we move forward to our today's segment, data pre-processing. If anyone have some
Uh,
question,
uh, Azam, I have one question. So
yeah.
this last tool that you showed me, this is very, I think this is very cool. I think this is exactly what Dr. Schwag is actually looking for as well, because uh, the request that she made regarding the tool for data cleansing, I think this is very much aligned with what she needs. So I think I'm going to just make a point of this. I'm also going to take a screenshot. I'm just going to send it to her because I don't think she has
Okay,
time to go through the.
we also preparing a professional tool for doctor and some other people,
Hmm.
which also
Hmm.
view the such view in the pure GUI format, and also the
Hmm.
pre-processing steps are also involving such tool. And because
Okay.
okay, and inshallah in the next week I also demonstrate such tool in the video format and in the live view.
Okay, perfect, perfect.
Ah.
Also, for all our attendants who are on the call right now, and also for anyone who later on goes and views this recorded video, please feel free to get in touch with Azam directly. For those of you in the WhatsApp group, you can message him over there, or you can send him an email as well. So if you have any questions which you are not able to bring up on the call, or you later on want to send it to him in a written format, that is also possible. And feel free to ask anything if you want access to what we're doing, if you have any questions, and don't feel shy. I mean, we have people in the on the call who are from different backgrounds. Some of them are from the medical sector, some of them are last year medical students. So we do not expect them to have knowledge about AI and IT and programming. So even if it is very baby questions they want to ask, they can always send us their questions and we will always answer them. And similarly, for students of AI and computer science who do not have knowledge about neurology and neuroscience and MRIs and brain scans, they can always ask us of those questions as well, and we will address their concerns. So it is a bit of a learning curve because we have people from two different backgrounds coming together, and our product that we are making it lies at the intersection of AI and health. So it's a learning curve for everyone, myself included. I have a PMP project management professional background. I don't have an IT background, although I have been running AI and IT projects for the past 8 to 10 years. So I do not know technical programming. So if you do not know technical programming, that is fine. You can always ask us on how we can help you take baby steps forward and move you in the positive direction. And similarly, for our medical students, if they are feeling lost or they are feeling that, okay, you know what, this is a bit too advanced for us, they can always contact us directly and we can always give them more learning and move them along with us. So back to you, Azam.
Okay. Now, first of all, we made some methods from the introduced some libraries which are dealing from the data pre-processing. There are different type of libraries, but today I am using the simplest type of two libraries which are used, which fulfill all the three or four needed data pre-processing steps for the MRI. The first library is SimpleITK. SimpleITK is a library which also available all the methods like data augmentation, intensity normalization, and skull stripping, and other and the NI template making and the tissue segmentation and other formats are also involved in the fMRI case like the time slicing and the correction. But now we are dealing the MRI. The fMRI is the advanced form of MRI, which involve the time sequence and time series. And basically, such machines are not as common as just like MRI machines. These machines are basically specifically designed from the Alzheimer and Parkinson and such like typical diseases because these diseases are not detected in the simplest form of MRI format. But now we're dealing the imaging and just deal the three, just like the models, the initial models are also built on MRIs. Now the second library is Nibabel. This library used from the loading and the visualizations of the MRI images, and the other library is scikit-image morphy, and such like scikit-image is the main library, and morphology is a other package of the library and and the Matplotlib. First of all, we import all the libraries, and after that, you also check that the all the library versioning. Sometimes some methods and some procedures are not running due to the versioning process. Now this is a basic command print and the library name dot underscore version underscore. This gives you the versioning of the library. Similarly, we apply all the libraries. You import that first of all the sklearn library. And also we check that which version we import such library and also apply the print command on such library. This is the baby steps of little steps which are we are using from the understanding of libraries, okay, how our libraries and how we deal that. Sorry. Now you see that it also gave the versioning 2.40 version. This is a way to check the all the versioning of your libraries. And the next step, basically, we apply, in such case, we apply a class level method. This is a high level programming method. We made a class, and in such class, we define different type of methods. The definition of the class is from the variable, from the reserved word class, and this is the class name. We made a class of brain MRI skull stripper, and you see that this is basically the comments of regarding how this class is dealt at. A class for performing skull stripping on brain MRI scan, sport ball T1 weighted and T2 weighted MRI images. Basically, over we deal two types of images in MRI: T1 weighted and T2 weighted. T1 and 2 we weighted regarding to the pixelization and some other features. When you go to the some documentation of T1 weighted and T weighted, you also better understand that there is slightly difference between that. And after these are we made a main method, which is basically init method is a main method which is initialization of class, and then we made a method of load images. This is basically professional type of programming. We made a different methods in a class, and now we utilize such method in different other classes. This pattern is basically applied from PyTorch programming. But in case of the TensorFlow, normally the people using more similar using the TensorFlow, they are using such method just like that, play the button, and this is because the easiest way of demonstration. But when we built a bigger program and big a routine program, just like making a tool and just like making a model in PyTorch, in TensorFlow, we made a method and different classes. That's why I give you some little methods regarding to the practice point of view. First of all, we made a method of load images. This is a method name. Def is a keyword. We represent the Python from the definition of method. And this is the parameter which get in the method. We get first parameter is self parameter. Self parameter is the parameter which is self-calling of the method. And second parameter is the mandatory parameter, which is file path. The first parameter self is non-mandatory. You send a blank word from that. But the second parameter is mandatory. When we call a load images method, we must give the file path in that. Otherwise, it gives the error. And just like that, we made a code that for a file start with ni or file with ni load. This is loading of the different extension of a file. We also give a DCM file, DICOM file. Now I am not doing the DICOM file. DICOM is the other format for MRI. Now we deal the only the NI Nifty format. Basically, mostly machines giving you the file format of MRI in the Nifty format. But in some cases, the format is in DICOM. There is some little methods. We also convert all the MRIs to Nifty format. Now the load the Nifty format, and after loading that, we make a method of save images. This is a method of saving the images. We make a output path, and output path we and also to check that if our file is a loading file is ni that then the method is run. Otherwise, you give exception of that your image is not in proper format. Fine is also another routine from the saving of method, the alignment of method, which also provide a ni file. And in this third method, we made a pre-process method. Basically, in the pre-processing, some pre-processing steps like before skull scripting, we also pre-process that the normalize simple normalization, not intensity normalization. We apply simple normalization and some noise reduction for our images. We apply such method. And lastly, the method which are dealing from this is skull strip method. You see that the parameter we are giving that first parameter we giving that the 3D data. This is the MRI, and second method is also a threshold method. Threshold mean some values for the filtering of our data. OSTO, OTSU, OSTO is a basically is a filter, thresholding filter, which also provided by Morphe library, SK library given from us, and some filter are applied. These filters are also available in the documentation when we you goes to the documentation of such library like simple ITK and SK image. You also give the all the methods available in that, and also give some examples. I also took some examples from such data because these things are not crammed that these things are available in the library. First method is we apply that also, and the second we apply adaptive. Basically, some features are not covered in such method. That's why we are applying two methods. This is basically a hybrid approach, applying that. And after applying that, we give some other masking method like morphology, small remove small objects in the brain mask and other things that, and searching applying after applying that, we return a brain mask and stripping brain mask image from the over. And the last method is applied that for the visualization of our images. This is a method for the plotting and visualization of the image after before the plotting the is that, and after applying the script what is the structure of the image. This is basically, and this is the basically the whole pipeline, which is this is basically way which you made a model and which made a processing pipeline. You see that we apply all the methods calling in such pipeline method. First, we load the images. Second, we pre-process the images. Third, we skull stripping, and after that, we save that images in the after skull stripping, and then we visualize that image. These are the, and we apply such methods and give the just giving the input and output path. First we apply self dot input load image and give the input path, and second we apply similarly the process method and give the data. This is data also apply, and second we apply a skull scripting method. Skull scripting method is also defined above that, which is the pre-processed data and the method we use, because we use two methods. At the one time, we use also a one method. This is basically terminology of the pre-processing of skull scripting. Now we run that. After we running that, you see that there is no error and the good sign is available that. And now we make a just like that. We give a disease 01 library. Basically, MRI input. In MRI input, we have disease Alzheimer disease 1 and disease 2 MRIs are available. And we get a first MRI as an input file and second output file is available that, and we take a name of skull strip brain 01 NI. You give your name according to your requirement. And after we applying that, we run this method. You see that after running the method, you see that this is the basically pattern of our method. This is the basic simple library for the skull scripting. Other fine-tuned libraries are also available in that. You see that in the original format, and original part after the brain masking is a mask of our brain. We give a mask of a slice, and after slicing, yeah, you see that is purely segmented that the things, gray matter and white matter and the blackish area of the area. And after applying that hidden cam and explanation method, we also colorize this thing in the tissue segmentation and other hidden cam methods. This is basically the skull stripping way how we strip skull strip. And basically in skull stripping, we use the library which is used that I am using not simple ITK library. I am using in such case scikit-image library. But in second case, similar example, I use the second library. I am using that. In such case, I am using the simple ITK library. Basically, the simple ITK library is too much easy that now I prepare all the example by using such library. Similar code that, but similarly I change one library in such case. First of all, we have disease, simple disease, and you see that. And this is basically gem. This is library. The masking is not better in such library case. You see that the mask is not prominent. Only give the black area and the masking that the masking is not betterly performed in such library. Now, this is basically the first example. I prepared the four examples for you people. First for skull skipping, and I use simple SITK library for all the examples. In the previous case, I use some advanced library, but in the such case, I prepare all these examples in one library. But if it's your people task, you explore different library. I told you that you apply that Moon AI, you apply that FSL library, you apply some other library because such libraries are not covered in just like a single 1 hour lecture because some complication and some other things are involved that after we prepare you such things, then we also demonstrate you that some advanced library, all these steps in the future when we dealing about the modeling of our models. First of all, the simple example, we also get similar code, and this code is too much simple is that. You see that we made only just one method. This is skull strip MRI. In such method, we take a input path, output path, and visualization. Either visualization is required, either visualization is not required. This is the basic three parameters which are giving in the model, and also these things are written in the arguments like input path, path of the MRI input. So you see that in my case, I made a folder of MRI input and output path. I made a folder MRI output path, and visualization is the visualization of the graph, and return you the stripped array या mask array is a returning form. First of all, we make a little steps for the processing of such process. First, we load the data. and the SK read image is also read data. We are not using NY Bible. We also use this STKI library, which is the read the image, and after reading the image, we convert the image into float format in the pixel format. Then we apply the SITK library post to threshold image filter and up to giving some value for the masking. Then we apply a mask. Mean we apply a binary fill holes method, binary morphe, morphological closing, and opening recursion. These are the methods for post-processing of like the better skill stepping of the data. After we apply a mask on that, and we save the data in the output part, and the last we convert our strip array and mask array the conversion for the visualization purpose. And this is a visualization plotting of visualization. We import a Matplotlib plot and we get a slice index. This is a method which we take a middle slice index of the MRI. You also give that the number as a slice index equal to 140, a slice index equal to 130, but we get a prominent because sometimes the middle of the image, if we get the MRI, which the images are not 256, then the middle is not 142. The MRI is depend upon the 150 images, 160 images. That's why I use such method. This method also calculate the middling index of the image. Now we plot the figure size. 18 by 6 is a plotting size, and first plot is that first plot we get array images and get the image slice and give the color of gray, and the name of the title is original MRI. And secondly, similarly we take a mask array image, and in third is a strip format image which is stripping after stripping. And this is our method is one single method. I complete all three things. These terminologies apply all the pre-processing method for the A's of you people. And this is the implementation of our method. How we implement this method? First of all, we give an input path. You see that we give an input image, an input image these two images. Then we output give an output path. You also give your name of your output file image. And when we apply this skull strip MRI method, input, output, and visualization giving because we need visualization. And when we apply visualization, you see that we have visualized data. But in such case, I also explain you the simple SA also not very good on applying on that brain mass. As you naked eye, you see that both the images look like the same, but you deeply when you deeply visualize such things, there are some things which are cleansed that in this stripping format. Now, if somebody have some question at that point, then we move to the next
Uh,
two points.
uh, uh, Azam, I'm going to have one question for you.
Yeah.
So, for everyone's benefit, I probably have the answer to this question, but I'm asking this for everyone's benefit. So, what is the current state of the art? Now, you've described how our model is going to do all these processes, whether it is skull stripping or intensity normalization. Well, you just spoke about skull stripping, so I'm going to speak about stripping. So, currently, what are doctors doing for skull stripping? What models are they using? And how is your model going to be better than what they are using right now? Just a couple of points
In
you can
the
give us.
in the current way, the doctor are applying all the things in manual way. You just down upload the MRI and apply some triggers, and sometimes the triggers are not properly applied at. In our case, our all system are automatic. Just the doctor apply some check boxes, and all genes are fine tuned according to that. In normal and because we apply different hybrid techniques on one thing. In just the simple example instruct shipping, this is just like a teaching point of view, but in the professional point of view we apply different hybrid ways how the better way to cleanse the data and the better way the performance of the sculpting is performed at. Similar that the other process that normalization and template building. If we the template building is not a easy task. When we made a MNI template, the MNI template is not available just like that. You give it some toolbox like CAT and other Clinica, and you give a MRI, different MRI and MLI tool is available. But our case, you just give the two paths, not a path. You just give a click, and your template is already developed in your site, in your repository. These are the things which is from the doctor for the pre-processing of the MRI and some other explanation AI when we apply a gradient cam and other things that which also explore the black box of the prediction, because in a normal case you also predict that the person has the Alzheimer, but you do not know the what is the understanding of the images. When our model give the reports from the doctor, and the doctor check that more than 20-25 slices, these slices are in better view, and all the slices indicate that which point area is a mild and which point area is detect the early detection. These is the main specialty of our models. uh,
Okay, that's a good response, Azam. Thank you. I will note that. Ahmed Al has a question for you as well. So he's basically wants to ask you, he's just messaged it in the group. So he's asking, is it possible to segment specific neural tracks from just a single MRI?
is it possible to segment simple neural track for just
Yeah.
MRI? I don't understand.
Yeah.
The neural track means all slices of MRI. Ahmed, are you Albert? Are you? Uh,
Yes, I'm
Ahmed
here.
Alissa, please.
Can you guys hear me?
yeah, yeah, I hear
Yep.
you.
Yes.
Yeah, what I meant, for example, in the brain, there are multiple tracks that connect multiple different areas of brain together to perform a task. So I was wondering, can you segment these tracks alone? For example, the track that's responsible for processing auditory stimulation. Can you segment them just from MRI, or do you need more advanced imaging formats?
MRI basically we deal firstly for MRI. In other case, when we deal from time slicing, we deal for fMRI. In fMRI case, we also dealing from the time slicing. In your case, when we join different slides as a time frame, then we deal on the MRI, fMRI, because in MRI there is no time frame framing. It is also available in the slices. We also connect some slices in the timing through programming, but the fMRI is better way to tracking the slicing of the MRI.
I see now. Thank you. So basically, we need an fMRI for such tasks.
But the fMRI is not in all cases, because the fMRI is not in the case of bone scanning and other things. Basically, the fMRI basically designed from the specifically from brain diseases, because the brain diseases are other things involved in that. And we
Yes, I'm
also
just going
deal.
to, Adam, I'm just going to add something over here. So, based on discussion that I recently had with a neurologist, and Azam, I think I know I've passed it on to you as well. So I asked the neurologist why the difference. Obviously, I know the difference between an MRI and fMRI. And for those of you who do not, it's basically that MRI is a series of images, while fMRI is it gives you a more holistic approach and a report, and it gives you a series of images that you can look at. Basically, it helps you in the sense that it when you want to trigger the brain, when you want to see the response of a brain, MRI is somewhat static, while fMRI is very dynamic. It can give you a response on how the brain is responding to different actions or to different triggers. So that was one major difference that the neurologist told me between an MRI and fMRI. And they also
Yeah,
told me, this gentleman, that the fMRI is very important when it comes to specific brain diseases like Alzheimer's and dementia that we are trying to research right now.
yeah. Basically, in fMRI, we also deal the temperature and other things like blood oxygen, sunlight flicker, which are also affecting from the brain tissues. These things are not noted down in the simple MRI. These things are also available. Data is also available in that. Now move forward that the second step is over is that intensity normalization. In intensity normalization, all the methods are preparing in the similar symmetries. Some triggers and some methods and some just like that, some values and some attributes are changed, but the hierarchy of all these methods are similar that because uh, we made different type of programming things, but I feel that all the things skills are simpler to simpler for the understanding of you peoples. And in such library we also use already such library which are or previously used for skull scripting. And the method in this method we also use input path, output path, and lower percentile and upper percentile. This is basically two values, 1 to 99 from the normalization thesis and also the visualization. You see that we also give the comment in such section. Lower intensity cutoff 1 to 100 and such values are, and which value is basically you apply the experiments on the fMRI, and after the experiment you better understand that which values are better in which case. Similarly, the load of the images and second method is the, for the calculation of the percentile, as we explained that the NumPy is the library which is dealing for the mathematical calculation, and percentile is a method of statistics. This method gives the two parameters like image array and lower percentile value. Similarly, we give the upper percentile value and image array. And in the next step, we apply a normalization. Intensity windowing is a method which is applied for normal intensity calculation. And after the calculation, we get the data in normal array and save in the path. And then similarly, we visualize that in the format of three format. Just like that, in first format is the original format, the second is the normalized format, and the third is after the intensity the distribution. And we just run this method for the better understanding. And similarly, you see that we give a one MRI is the input and other MRI is the output format. And when we apply that, you see that we have such like a picture. First picture is our original MRI, and second is a MRI normalized. And this is the picture which you explained that how level the intensity level they clear the paper. And these original and these normalized. It means that the over picture is that over picture is originally in such level is normalized. When and the after normalization just give the just such level of intensity, 1 point something level. And when we apply, let's suppose we apply some figure, we apply a 10 value and we apply the intensity level to 90, and we check the experiment, what is the difference between the experiment. And you see that there is little bit changing about our normalized value. If we give some harsh value, just like we give 20 lower and upper we give 80, then you see that when we give the values are not proper way, you see that over original image also not visualized, and you see that the normalization is not done that because we give the wrong values for the percentile values. That's why These all the values and best possible values and best possible is in um, machine learning language. These things are called weights. Best weights are also available by researcher in these sites, and you can read the research paper and you get collect the best weights, which weight is best from the best calculation. And in the previous, Sir Ahmed also asking me what is the difference between the normal things and what is the difference between uh, over tools and over technology, because we collect the best things which are not mostly people are not we experiment on that things, and after getting result, these values which are giving me the better results which are embedded automatically in our programs, and you people just like use such program and give your desired outputs. And you see that when we give the better way, you see that the density normalization is better way. Now we move forward the tissue segmentation. Tissue segmentation is also very important part, because this is the part of the MRI which is very important from the explanation point of view, because in this part we extract the features. When we you read the different ML and deep learning literature, you also see that in a diagram, you see that one thing is mostly used by different people, and it's basically the second steps of the data processing. The step is feature extraction. Feature extraction is just like tissue segmentation. In our case, the tissue segmentation is a feature extraction in our case, because this is the main part which we get the tissues and the values of the tissues and the nature of the tissue, how the tissues shape, and after experimentally take the different images, we train our model, and in the right time when we upload a unseen MRI, our model detect that, and our model also explain that which tissue parts are basically early Alzheimer detection. Similarly, we made a method from segment brain tissue, and similarly we give a same sequence. One library sklearn is also applied in such case. K-means is also a algorithm which are basically using from the calculation way of some typical things like gray matter, white matter, and CASF segregations. Now, first of all, we give a input and output file path. Then when we call the method and loads the image, after loading that, we preprocess our image and apply some normalization things. And in the fourth step is that when we apply a k-means, k-means is a formula which we apply, which we made a cluster, because all the things are cluster means a portion of area, a chunk of area, because when we see you the example, you see that these are the chunks of yeah. You see that the gray yellowish area is a chunk of cluster. This is a cluster. This is a cluster area. And similarly, the yellowish area is a cluster area. These and this is a bluish shade is also a cluster area. These are the cluster areas which we calculated over k-means model. And after the calculation, when we calculate that, these things are also available in the library. When we go to the libraries, these methods are already built in bus, but you also utilize such method in a better programming way. First of all, we apply a k-means, and given the cluster 3, it means that we made a 3 cluster area and 3 points, and after the random state is 0, then we calculate the shape means we calculate the pixels of the data and which pixels are allocated just cut cluster, and then we apply the fit predict is a method which also predicts that these clusters are basically allocated in the same way, main same segment, and after that we label such segment, and after that labeling we apply a array algorithm, and we create all labeled that all the three areas: CSF mask areas, GM gray mask area, VAS, and white mask area. And after that, when we get the areas, we convert such areas in the form of pixels. You see that we convert back to image format. First we convert the in the pixel format, then we convert to the such areas on the image format, original image format. Then we apply that a other loop, and after that we make a result, and after result we make a we write the all the areas, similar all the areas NI files, means a separate MRI file for the doctor point of view, yeah, further explanation AI point of view. And after that, we visualize our MRI, and you see that we visualize a plot in CSF, GM, and WM. And after applying that, we apply that. Now we run these. Now the program is running. Now you see that we give example of some other MRI. We give example of 02 MRI, and you see that after applying that, it takes some time. You see that see that original in fMRI, and after the tissue segmentation, this is basically a color combination. You see, you set your color combination according to your point of view. You see that it is a whitish area is from yellowish, and this is the area which is grayish area, and some is fluidish area is a blackish area. This representation original area is over in such example is that, and CF area is that. These are coloring are also in the color bar. Now, if somebody have question, then we wind up the last step of today lecture. If somebody have some question, please ask me.
I
Azam, I'm just going to add. Yeah, sorry, Zayan, please go ahead. Go
no,
ahead.
it's okay. Please go on.
No, 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 that's fine. Go ahead.
Okay, thank you. Mr. Azam, I was wondering whether we have to use the same parts and sections of codes, or should we like the ones you used, both you and Dua, or do we use random ones?
Which part are rendered? All the parts?
No, like for the compiling for the assignment you assigned us last week. So do you use like random parts and just gather them, or do we use the same ones you actually demonstrated on?
No, it's in last lecture, the Dua also demonstrating the loading and visualization of the image. In the first part, I also give some code. I also upload that the 3D view of the data. But in the such part, we also do the all the 3 or 4 method of data pre-processing, and all the things are also uploading on the GitHub code, and I'll share you already. You run such code on your side and change some value, and take results on your side. Then you betterly understand and demonstrate that thing. You change some things and remove some things you got an error. You also understand such error. If you have a problem, you discuss me regarding such error, and such time you better understand that. I believe that.
Okay, great. Then do we upload it on GitHub and then send you a link, or?
You give me a voice message, yeah, on my WhatsApp number. Yeah, you give me some voice note, yeah, some written note, yeah, in case of some email is also available. You.
Okay, great. Thank you so.
Azam, Azam, so Zayan will be in touch with you then on WhatsApp and email. Zayan, then you
Okay.
can make those. Zayan, so you will go on that GitHub link and then get the link from there and then do the experiments. And then
Okay,
again, that's good. We that again that we encourage people to go and try it out for themselves because practice is the I think is the best teacher. So that's good. Azam, I have one more question for you. So these processes that our system, our model will do, skull stripping and intensity normalization and data augmentation and the other stuff that you mentioned, the registration, for example, to the MN152. What I'm thinking is there a one-stop solution that you upload the MRI and press a button and it does all of
Yeah, yeah,
that?
yeah. It's a
My que
one step process, and you have an option that
my Mhm.
when we practically giving the tools from hospital doctor is a step process, and the process you have a process bar which you also explain you what process is completed and what process is it's just like 1 or 2 minutes process, and after process that a report is generated in some like visualization of plotting form, and yes, yeah, in the format of you download in the format of PDF, such like that.
Okay, okay, that's good. And the PDF download can be both in English and Arabic
Yeah,
language. Is
yeah,
that
yeah,
correct?
yeah. It's in both language.
Okay, and one final question. Can we have a filter of some sort that gives us the option that, okay, we want to do skull stripping, but we do not want to do intensity normalization, or maybe we want to do
Yeah.
intensity normalization?
These filters are
Okay,
also available in that in the form
okay,
of checkboxes, yeah, in the form of some other radio buttons. You apply that, and
okay.
such process is that. Now I move forward to our last uh, pre-processing step is a template registration. It's also a very important part because from the model point of view, if our images are not in properly framed, template being in a frame, in not proper frame, our model is not betterly understand that, because from the reading of our model we also give the some easiest form that, and for the pre-processing and other point of views. That's why the different researchers suggest that the MNI from 152 template is better from the MRI point of view, and similar betterly from the Alzheimer point of view. This template is more important, and the different libraries are adopt some such MNI formats. And recently the Clinica and fMRI Prep is another two other libraries which are already advanced level libraries, because at these steps we are not including such coding because the people are new, and we believe that the easiest type of library understanding for the basic understanding. And when we move forward for the modeling over models, then I also give you the examples, and these lines are already 1 to 3 lines, and your process is also 2 to 3 times faster than such examples, and results are also better. Now you see that in such case we also similar process, we take input output, and also a verbose is also a parameter of boolean type, and we give a template available in a website. We get such template from that, and after getting that we extract the MRI template MRI image, and after images we apply some that over MRI. In If we have more MRIs, or MRIs are also templating in the form of looping. Now in our case we also deal with one MRI, and such like the process of the MRI, we run that because it take some time, uh, and you see that, see also, then we call disease is number one, and apply that is whether they're taking some time, then downloading the template. In such case we explain the code for you people, how the code is running that. First part of the code is just like the downloading the MNI template and make a template directory. In template directory, we create a zip file, and this is just like a directory hierarchy, and we extract the zip file. These codes are also available in the net. And after that, the main process is that after that, we moving over images, we reading over images from input path and moving over images to such template. Initial alignment, such like that center transform initialization and irregular 3D transform. This is basically geometrical alignment of the method, which also involves the data augmentation, because many data augmentation part is also involved in template registration. You do not need to apply separately the all the methods. The template making handling all the methods. And after that, we registered the metric isolation method, the metric sampling strategy, metric sampling percentage, and optimization gradient descent. These all methods are applied for the registration. And after registration, we apply that methods. We execute that the method for the transforming of one image to template image. And after the applying that, we make a directory of the output and save the images in the registration format. Now, after that, 1 or 2 minutes, the things are in the template format. Now, in the last 2 or 3 minutes, if somebody have a question, ask me. And in the next, I hope that, and I also advise all the people that you all people just run such code on your side. It builds your confidence, and also you get a lot of questions from the next lecture, because in the next lecture, I suggest you people you get some questions from the old area, and during the week you also giving me your question through any type of mode like WhatsApp, like email, yeah, telephonic voice note, whichever feasible for you. And you see that the method is compiled at, and after the compilation you see that this is a better way of the ML and ML, because you see that in the first case over MRI, you see that for the MRI in the first case, you see that over MRI picture is that this is our first MRI picture. You see that after the template, all these part is removed by the templating. So in the template format, you see that all the part is removed. You see that all the part is removed. These are the basic images which are available from you people from computer vision, because but in our case we deal zero to scratch all the things on the utilization of different libraries, because in this way you train your model betterly and in a real time, and, yeah, and you can claim that you get a pure raw data and you process your data your own schema. This is a professional point of view, and professionalism is that. So if somebody have a question, ask me.
Okay, Azam, so Dua has sent over a question. She basically wants to know whether data augmentation and tissue segmentation always need to be used together in a pipeline, or can they be applied individually depending on the use case?
They depended on the use case, but I suggest that in the first way you apply that the skull scripting, and the data augmentation. Basically, data augmentation is normally applied before the template registration. Tissue segmentation is before the template registration, because the template registration is the last part in which you and somebody depend on the scenario. Somebody made a template in the second step, and utilization of some template they applied tissue segmentation. They depend upon the results and depend upon the clarity of the MRI. Sometimes the MRI clarity is too much good, and we apply not so much data augmentation things on that. But sometimes the resolution and some other things are not too clear, because when we clear such thing, that then we apply tissue segment, because tissue segmentation is the main part for the feature extraction.
Okay, got it. Thanks for the response. Now, before the call ends, we only have a few minutes over here. So I'd just like to make a comment that thank you for everyone for joining in. I see Dua has joined in from Canada as well, and I see Mustafa after a long time. We see him, so that's good. And I had a very good chat with Ahmed Alissa yesterday. He's also on the call. He's one of our very few people who was joined right at the beginning. He's also working at King Faisal Specialist Hospital and Research Center at the moment. Now, this is the same organization that we are going forward with the MOU and collaboration with during the summer. And we had a very good discussion yesterday about a potential couple of things that we can do. So we will be joining forces and collaborating with other groups of doctors and young professionals as well who are focusing on neuroscience, and we will get them on board to be a part of our research and development collaboration. And aside of that, there's an Alzheimer's awareness campaign that we also want to run this summer because, okay, we're building a solution for Alzheimer's, this is good, but we also need to educate people on what Alzheimer's is. So I think that's going to be a good endeavor. We're going to do it digitally, and then we're going to have some sort of an on-ground event in Saudi Arabia as well. I'll probably be visiting next month, inshallah. And yeah, that's about it. Do stay in touch. Do connect with us on LinkedIn. Do spread the word to your friends as well. And if anyone has joined late, they can always go back to the YouTube recording. And inshallah, next week we will have another session, and I think Helio will be joining in next week as well. So we will see what the agenda for that meeting is. And have yourself a very good weekend, inshallah. And we will talk soon, everyone. Thank you very much.
Okay, thank you for all. Thank you. Allah Hafiz.
Allah Hafiz. Thank you.